Well, in the last video, we talked about how to write the equation for an acid-base reaction. And in this lesson now, we're going to be learning how to do stoichiometry with acid-base reactions. You're not surprised, are you? Stoichiometry seems to be creeping back in almost every single topic that we do. So what happens in an acid-base reaction is that, as you learned about pH in the last section, you know that acids have a pH lower than 7, bases tend to have a pH higher than 7. And so when you have an acid and a base and they react together, if they react in equal proportion to each other, they will completely cancel each other out and you will have a solution that has a pH of 7. So that's called neutralization. They are neutralizing each other or canceling each other out. So what we're going to be trying to find out today is, if I have an acid-base reaction, how much of, if I know I have a certain amount of one, how much will I need of the other to be sure that they're going to completely cancel each other out? So I gave you a sample problem for video number 5, so that's the one I'm going to be working right now. It says a chemist wants to neutralize 32 grams of KOH with a solution of 4.5 molar H2CO3, which is called carbonic acid. How much carbonic acid will he need? Well, anytime that you have a neutralization problem, an acid-base problem like this, the first thing that you have to do is write a balanced equation, because you're not going to be able to do anything else until you get that done. Okay, so in this particular reaction, I am reacting H2CO3 with KOH. And as we talked about before, this is a double displacement reaction, so we're just going to swap partners. My potassium is now going to go with my carbonate. Potassium has a positive 1 charge. Carbonate has a -2 charge, so I'll need 2 potassiums in order to make that balance. Then my hydrogen is going to go with my hydroxide to give me water. Then I need to balance my equation. I've got 2 potassiums here, so I'll need 2 over here. I have 1 carbonate here and 1 carbonate over here. And then what I'm left with is 2 hydrogens and 2 hydroxides, so I will need 2 waters. Okay? Now that I have a balanced equation, now I can do the stoichiometry calculations that go with this. So I was told that I have 32 grams of KOH. So I have grams of the given, 32 grams of KOH. And just as we were doing the stoichiometry before, I'm going to take grams of the given and I'm going to go to moles of the given. So in 1 mole of KOH, if you look at the periodic table, potassium is 39.1, oxygen is 16, hydrogen is 1.01, and so that's going to give me a total of 56.11 grams of KOH. So the grams of KOH will cancel out. So I have moles of the given. Now I need to go to the moles of the asked for, and you'll remember that that always comes from the balanced equation. So I need to put moles of KOH on the bottom, and from the balanced equation there's this coefficient of 2 in front of there. So I have 2 moles of KOH, and I need to find carbonic acid, so that's the H2CO3. There's a 1 in front of there. So I have 1 mole of H2CO3. So moles of KOH now cancels out. I'm looking for volume, so I don't want to take this down any further. I don't want to convert that to grams. That's not going to help me. So when I do this math, I end up with 0.29 moles of H2CO3. And the problem tells me that I have 4.5 molar H2CO3. So if you'll remember, the number of moles divided by the number of liters gives me molarity. So molarity equals the number of moles, 0.29 moles, over whatever volume I'm going to need, okay? So when I solve this, and again, we've done problems like this before, so you're going to multiply both sides by x, and then divide both sides by 4.5, and so that will give me a final answer of 0.064 liters of H2CO3. Okay? it really shouldn't be anything new here. Basically, we're still doing stoichiometry. We're still working with amounts in liters. We're working with molarity. We're working with grams. We're working with balanced equations. So basically, we're just transferring the knowledge that you already had with all of these things now to an acid-base reaction.